All right, good morning, guys. This is 12.5 volumes of pyramids and cones. Remember, surface area is what you could paint on the outside, and then volume is what you could fit in the inside. All right. Okay, so with the pyramid and a cone, it's based off of the original volume formulas that you learned the day before, which is base times height. And a pyramid, if you fit it inside a box like that, it's just a third as much. Therefore, your formula is going to be in this. This is what goes in your notes here. Volume of a pyramid, we have volume equals 1/3 base times height, where capital B is going to get replaced with a formula. And then you got yourself volume of a cone. Oops, sorry about that. There we go. Volume of a cone, which is just this last part here. So it's V equals 1/3 pi r squared times your height. So same formula, you just got to throw 1/3 in front of it. The problems on today's lesson, they challenge you a little bit. The first ones won't seem too bad, but then the next ones will be a little bit more work, but we'll just kind of get through it here. All right, here we go. So the first one, this is a pyramid. So the formula for volume of a pyramid is 1/3 base times height. Volume equals 1/3. Okay, your capital B gets replaced with a formula, and then your base is a triangle. Therefore, it's going to be 1/2 base times height. And then you still got that H on the end, which is the height of the pyramid. Okay, so let's highlight our base here. It's a triangle. It's right in there. Okay, so let's focus on that. Base of the triangle is 4. Height of the triangle is 6. Height of the object is 9. Right, and then final answer for this guy. After you multiply those out, oh, okay. So fractions. Here's what I do. You follow PEMDAS, so it's all multiply. I take 9 times 6 times 4. Hit enter. Divide that by 2. Push enter. Divide by 3. Push enter. And final answer would be 36 meters cubed. Volume is cubed. Moving on to the next one. So we have a cone, and probably the biggest thing you should focus on is the 4.5, whether that's height or that's slant height. Now it goes straight up and down from the base, so that's going to be your regular height. The volume for a cone is 1/3. Don't forget that 1/3. And then we're going to use a cone, which is pi r squared h. And one more time, make sure you grab the height and not the slant height. On this one, they give you the height, which is 4.5. And when you are all said and done, that's 22.8 centimeters to the third power. Yeah, cubed. Volume is cubed. All right, moving on. Okay, so what they do is they tell you the answer. The volume is 2,026,450. The regular height, so imagine you could drill a hole in there and you could start from the center and work your way straight up, right? That's 144. So just by looking at this right now, take a guess of what the side length is, because that's what they want you to find. How does that compare to the actual height of it? Just so you have a rough idea of what the answer would be. And here's how you actually do the problem here. So you guys know that this is a pyramid, so our volume formula is the base of this object is the bottom. It's in the shape of a square. So on this problem, it does help to use this. I don't use it very often, but it does help to use s squared. And if you don't like s, you can use an x instead, but side squared is the bottom. And then your height is the distance from the bottom up, and over here in the original formula, they give you or the directions, they give you 144. All right, you're solving for s, so you want to reverse PEMDAS. Okay, so here's what we'll do. I would divide by 144 as my first step to move that over. Okay, and I'm going to not show work because I'll run out of space here, but divide both sides by 144. Okay. Second step, multiply both sides by 3. Take the square root of both sides. Now it's just meters. The side is 215 meters. So remember I said earlier, if you'd imagine the center going straight up, that's 144. And this appears to be, about that. It looks a little bit more, but 215 would be the side length of the pyramid, and that's in meters. Okay, this is a problem that it's really good. It's one that's grade level. Like I would want you to know how to do this particular problem. Here we go. So it's a pyramid. Here's the formula. 1/3 base times height. Okay, area of the base. Or sorry, the base is in the shape of a regular hexagon. So shade that in. A regular hexagon has the formula 1/2 AP. So start with 1/3. And then you go 1/2. And then an A, apothem, perimeter, and you still got the height. Okay, I'm feeling like crazy. I'm gonna have to move this off to the side eventually here because I'll run out of space, but away we go. So let's go with this. Let's go fill in the very, very last one. The height of the object is 11. We can grab that pretty quick. So that's 11. The perimeter of your base is 4 times 6 because there's a hexagon, 24. Which actually just leaves us one thing to find out, which is the apothem. Now I'll try to fit it on here, guys, but you remember how we do the center on down of a regular hexagon? So we'd find the central angle, which is 360 divided by 6, and then divide that by 2 to get the reference. So we're looking at 30. Ah, crap. So I'll fit it in here, 30, right there. Okay. Now we know the whole bottom's 4, which makes this part over here 2, and you're looking for the apothem. The trig function that uses opposite and adjacent is tangent, so tangent of 30 degrees equals opposite over adjacent, put a 1 on bottom. 2 equals the tangent of 30 times A. Divide both sides by tangent of 30. 2 divided by tan 30, and your apothem ends up equaling 3.46. Okay, so let me kind of grab this stuff here and possibly move it to the other side. Oh, don't want to do that. Let's see, is this going to work? Maybe. Okay. All right, and then our final answer, after you multiply the whole phrase out, come up with 152.24. Dimensions yards cubed. All right, so we got a cone, and volume of a cone is this. Okay, they don't give you height, they give you the slant height, so you're gonna have to use c squared equals a squared plus b squared. So I'll have to ballpark it here because I didn't have this written down here. So it'd be pretty close to 6 point, we'll say 3. We'll say 6.3 would be there. Be the height. So we'll go 6.3 right there. So you'd multiply these 3 numbers out, and you'd get your answer. Okay, moving on to the next one. Okay, I think I'm going to skip this one. They give you the answer, and then you work backwards. So we already did one like that. And this looks like getting toward the end here. So volume of a cone. Radius you don't know, we'll have to find that, but the height is definitely 16. Okay, so you have a right triangle and you know the degree is 65 degrees, you'd like to find the radius. The trig function that you would use if you would like to know r, and this is 65. Right there, that's 65 degrees, and this is 16. Okay, think of the trig function that uses the opposite over the adjacent. That'd be your tangent. Tangent of 65 degrees equals 16 over r. 16 equals tangent 65 r. Divide by both sides by tangent 65. 16 divided by tangent is 65. And 7.46. Put that in place of your radius. Multiply all of them out. But when it's all said and done, this is what I ended up getting for this guy. Okay. All right, so a little bit tougher. Had to use a trig function. And I think this next one here, I don't have it listed. Okay, I got to wing it. All right, here it goes. So they have a, this is going to be bad. Let's go this route. They have a box on bottom, and so let's go this route. And they have a pyramid on top. Let's see how this looks if I do this. Not so good, but you get the idea. Okay, so it's a pyramid with a box, and you're supposed to find the volume of everything. Now, one nice thing about this problem is the dimensions were all 6. Even the height of the pyramid. So I'll try to draw it in here. So from the center of the pyramid, straight up, so that is the height. That was also 6. Okay, so here's what you do. You got the volume of a box, which is length times width times height. We're going to put it together with a pyramid, which is 1/3 base times height. I hope you guys don't mind, but I'm going to erase the capital B because the base of the pyramid is basically a square, or, you know, we can use, we can use length times width on that guy. Length times width, and then we still got the height. Okay, so we'll fill in these numbers here. Okay, on the box, you got 6, 6, and 6, length, width, height. But on the pyramid, you notice that this is also a 6 by 6 for your base, 6 by 6 with the height of 6. So if we figure the one side out here, we got 216 plus, and if we figure the other side out, we get 72, which makes us a grand total of 288 meters cubed. All right, guys, and that wraps up the lesson. If you have questions, come see me in the morning. Be glad to help you out. If not, have a great day.